So this is Mount Taylor zoomed in with my Nikon P1000, and you can clearly see the mountain bottom up. But I'm viewing this mountain from 98.9 miles away. So what I did was, I marked 7 different elevations at the bottom of Mount Taylor to give me an average elevation of 8,337 feet. So the top of Mount Taylor is 11,305 feet. So that means the bottom to the top of Mount Taylor is approximately 2,968 feet. My viewing point is at an elevation of 7,175 feet. So that puts me 1,162 feet below the bottom of Mount Taylor. Okay, so just to recap, I'm 98.9 miles away. The bottom of Mount Taylor has an average elevation of 8,337 feet, so the bottom to the top of Mount Taylor stands at 2,968 feet. So even if I were to build a tower 1,157 feet, minus 5 for the viewing, so the bottom of Mount Taylor and my viewing point will be at the exact same elevation, so we can keep the viewing height at 0, then Mount Taylor would be obstructed by more than 6,500 feet of curvature, which is not observed. Another way you can look at this observation is if I minused the elevation to the exact viewing point. The reason that we can see Mount Taylor from nearly 100 miles away is because the Earth is flat. These are the numbers that are given. The globe's foundation is built upon the Earth's radius being accurate. That's how we calculate the curvature, Earth's spin, Earth's orbital speed, is all based off Earth's radius, and if there's 1 mile of missing curvature, the entire heliocentric model of Earth comes falling like a house of cards. I just showed you nearly 180 miles of missing curvature. Let's have a moment of silence for the globe. Okay, that's enough. You can't say that there's flat spots on the globe, or it's not a perfect sphere, or we live on an oblate spheroid. That's a contradiction in itself. The ISS live feed shows a consistent curve, and the total lunar eclipse shows a perfect curve as well. But that's all you're going to find while looking into the globular model of Earth. Contradiction after contradiction, because it's a lie.